to go.
All right, guys, lesson 3-4. Can you read the I can statement for me, please?
I can use area, model, and partial products to multiply.
Thank you. So for our solve and share, it says use only the numbers shown on the diagram. What numbers are shown on the diagram, guys? Lainey?
8, 10,
Those are the only 3 numbers you can use. So use those numbers and the operation symbols to determine the area of the unshaded rectangle. Not the green part, the white part. Unshaded, yeah. So go ahead, use those 3 numbers and any of those operation system symbols to figure out what the area is of the unshaded area. And if you need help with multiplication, remember you have a multiplication table on your name tag that you can use as a resource. Kartik, do you want to bring up your book and show me? And walk me through what you did and why.
So what I did is I saw like this was 8, and I did 8 plus this because I saw this was 6, the unshaded ones. So then I did 8 plus all these 6, and I counted it. Then I know 8 plus 8 equals 16. I did all 3 of these, and I got 48. And I put the 8 here, put the 4 there, got 48.
So it's 48 what?
48 unshaded squares.
Okay. Perfect. Aria, do you want to bring up your book and show me how you did yours?
So what I did is, I know that this is 8 squares on this side and 10 squares in all. And I know that this is 4. So I did 10 minus 4, that equals 6. So that means this is 6. So I multiplied 8 times 4.
Hold up, Aria. I just want to make sure that everyone's paying attention because you're doing a great job explaining. Okay, so 10 minus 4 was 6.
So then I knew that all of these cubes right here were 6.
Okay.
And these cubes were 8 since it says 8.
Mm-hmm.
So then I multiplied it and it
So 8 times 6, and you got 48 cubes in the unshaded area?
Yes.
Perfect, thank you, Aria. All right, so, let me rotate it. So, my brain did it similarly, excuse me guys, to Aria. So I know that this across is 10, and I'm looking for this part that isn't green. So if 4 of the 10 are green, I know that there are 6 that are not shaded. And I did the same thing, 8 times 6. And I looked at my multiplication table, and I know that 8 times 6 is 48. This is just another visual, just like the arrays that we did in our last lesson. This is the rows, and this is how many was in each row. So 8 times 6 is 48. Now, on the next one, it's asking us to look at these equations and see if they are equal. I know that with the distributive property, I can multiply any the numbers and it'll equal the same thing. So 8 times 10 and 8 times 4. So 8 times 10. And then you also multiply that by the next thing. But there's a negative number, so we would need to subtract it. And then 8 times 4 equals n. That looks like the same thing to me. Yes, Ethan.
Could I share my mistake?
I'm going to say no this time, just so that we can get through the lesson. Because remember last time it was pretty confusing. Our last lesson was kind of confusing. I don't want to bring something up here that might confuse some more people and get this one stuck again. We're just gonna keep rolling. I'm glad you found your mistake and you know how you can correct it. But this time I'm gonna say no. Okay, so 8 times 10 minus 8 times 4, is that the same as what was here? Yeah. Okay. So it is using the distributive property. Thank you, Sarah, for letting me know that you're done. Cassie and Camilla. Can you three go get Annie? Sarah, Cassie, and Camilla, please. Okay. Alright, so if you turn the page, this is what I'm going to show you on the video. So this is another visual, instead of the arrays, it's area models. So I'm going to have you guys come down to the carpet so you can see the video.
How can you use an area model and partial products to multiply? A garden is in the shape of a rectangle. It is 8 feet wide and 25 feet long. What is the area of the garden? How can you find the area of the garden?
Select your answer.
So how do you guys think that we will be able to find the area of a garden if it is 8 feet wide and 25 feet long? Emery?
I think we should multiply 8 times 25.
Okay, who agrees with Emery? Does anyone think we should add or subtract it? You think we should add or subtract it?
Yes, because I don't think there would be hundreds of feet of garden out there.
Okay, so do you want to add or subtract?
I want to add.
Add it? Okay. Add 8 plus 25? Doesn't look like it. Let's try Emery's. You said multiply, right, Emery?
Yeah.
Okay. Yeah. It's a big garden, I think.
Since the garden is a rectangle, multiply its dimensions to find the area of the garden. A numerical expression contains numbers and at least one operation. 8 times 25 is a numerical expression.
Repeat, what is it?
Numerical expression.
You can use a rectangular area model to show multiplication. The product of 8 times 25 is the area of the rectangle.
Do you guys see what they did there?
Yes.
He just drew the garden. 8 times 25.
8 times 25 is about 8 times 30 equals 240.
It's an estimation. That's going to be what we use to check our actual answer.
Break 25 into tens and ones.
See, I love what he did. 25 is a big number. It's kind of a scary number to multiply by. So if he's separating 20 and 5, what do you think you guys are going to have to do? Aria?
I think we might have to do 8 times 5 and then 8 times 20.
Yeah, and does that seem a little bit easier than 8 times 25?
Yes.
Yeah.
The smaller section represents multiplication of the ones. The larger section represents multiplication of the tens. 8 times 5 equals 40.
And this is the same thing we were doing in the last lesson, remember?
Yeah.
It was 8 times 5, we multiplied the ones place, and we write here that it means 8 times 5 ones.
8 times 20 equals 160.
Again, it's not 8 times 2, it's 8 times 2 tens. And they lined it up by place value so that when we add it up, we're adding the right numbers correctly.
160 plus 40 equals 200. Eight times 25 equals 200. The area of the garden is 200 square feet. The product, 200, is close to the estimate of 240. The answer is reasonable.
Yeah? Do you guys get it?
Yes.
And estimating is just a way for you to check. If you know that 8 times 30 is 240, if when you do it, you get an answer of 1,452, you might have done something wrong, right? So it's just a way for you to check. So 200 is close to 240, the answer is reasonable?
Yes.
All right, perfect. Can you guys please go back to your desk? Now, down here, it says, convince me, you need to construct an argument. Does 12 minus 4 times 2, is that the same thing as 12 minus 4 times 12 minus 2? Can someone raise your hand, or raise your hand if you think that they are equal? Raise your hand if you think they are not equal. Yeah, they're not equal. This equation does not use the distributive property. It doesn't use the distributive property. So I know that the first part of the equation, 12 minus 4 times 2. 4 times 2 is 8.
Yes.
12 minus 8 is what?
12 minus 8
Equals 4. Now let's see what they did over here. 12 minus 4 is 8, right? So they did 12 minus 4 times 12 minus 2. 12 minus 4 is 8,
Yeah.
and 12 minus 2 is
10.
10. 8 times 10 is 80. 4 does not equal 80. So if it ever gives you, for you to see if both sides of the equation are the same, you can always just figure it out and see if the answers are the same on either side of the equation. Yes, Lane. Oh, yeah. Thank you, table 4. Can you guys, or table 5? Table 4. Can you guys go there? Thank you for being on it and following along with me. All right. So on the next page, it gives us another example. 5 times 123. Now this doesn't have an equal sign, so I know it's not an equation. Can someone tell me what it is? Kartik? It is a multiplication, but in the video, it told us in Mariko, what do you think it is?
I think it is a numerical
Expression? Yeah, it's a numerical expression. There's no equal sign. Just 5 times 123. Now, for this lesson, we're using area models. Some of you might have liked the arrays a little bit better. Just think of this kind of as that. So 5 times 123 means that there are 5 rows of 123. So again, they did the same thing in the video. They split up 123. They separated the hundreds from the tens and the ones. So then we're going to have 100 and then 20 and then 3. And we're going to multiply 5 by each of those. So as it shows here, they did 5 times 100. That's 500. 5 times 20 is 100. And 5 times 3, which is 15. They also did it stacked. And again, it's 5 times 3 ones, 5 times 2 tens, or 5 times 20. Added it all up, and it was 650, or 615. So number 1 is asking what numerical expression is shown by the area model below. When you look at this, what is the numerical expression that they're asking us to solve? Aria, what do you, or Adria, what do you think?
I was just gonna say I'm still a little bit confused.
Okay. Can someone tell me what the numerical expression might be? Aria?
I think it might be. I don't really understand it, but I'm guessing. I think it
Okay. So, a numerical expression does not have an equal sign. It's like what the problem is. So 5 times 123 is a numerical expression. So for this example, we separated it so that we would have 100 and then another section with 20 and another section with 3. So this area model shows us that the numerical expression is 5 times 123. So for number 1, we already see the area model. It's asking us to kind of work backwards and figure out what the numerical expression might be. Marika, what do you think it is?
The numerical expression for number 1 is 7 times 265.
Yeah, it's 7 times 265. Who sees what Marika did, how he got that answer? All he did, he looked at the area model and saw that it was a group of an area of 200, an area of 60, and an area of 5, and he added them all together, right, Marika? Just working backwards. The first one we had the numbers, and then we separated it out. This one it was already separated out, and we changed it to numerical expression. Yeah?
Yeah. Yes.
Okay. So number 2, it already separated it for us. The numerical expression was 560 times 7. They separated it for us already, the hundreds and the tens. There's a section of 500 and a section of 60, right? Okay.
Yes.
So 7 times 0 ones is
0.
It's 0. Alright, we did that one. And 7 times 6 tens, this area right here, 7 times 60.
7 times 60 equals 420.
420. I'll make sure to line up my ones together so that I'm adding my ones together and not messing up with another place value. And then the last thing I need to multiply is 7 times 500, which is this section here. 7 times 500.
7 times 500 equals 35.
Ooh, 7 times 5 equals 35, but remember we have to account for all the place values. So it's 3,500. And then we would add it all up. 0 plus 0 plus 0?
0.
2 plus 0?
2.
4 plus 5?
9.
Nothing plus 3?
Nothing.
3. So the answer for number 2 is 3,920. Same math, just a different visual. So when you're using the area model, the visual, the 7 times 500 was 3,500. 7 times 60 was 420. Okay. Let me do number 3. You guys follow along. Can I get a fist of 5? How are we doing on this lesson? Got some 4s and 5s. It's just a different visual, but it's the same math as last time, right? Yeah, we're just looking at it a little bit differently. So number 3 is, I know it's 34 times 6. They've already had the expression for us, and then they separated it for us. So I know I'm gonna have to do 6 times 4 for my ones place, and 6 times 30 for my tens place. Yes, Owen.
Can I say what 6 times 4 equals?
Yeah, 6 times 4 is
6 times 4 equals 24.
24. So I'll put it there. I'll also put it in my area model so that I see that the area that was 6 times 4 is 24. And then, is it 6 times 3 or is it 6 times 3 tens?
6 times 3 tens.
Which is 30. So what is 6 times 30?
6 times 30 equals 1,000. 1,000.
Nope. 6 times 30 is 180.
Yes.
If the math is hard for you, you can always do another problem. So let's say you don't know what 6 times 30 is. 6 times 30, and I know that you guys were shown, if you highlight the place value, we still have to account for it. But we know that 6 times 3 is
6 times 3 equals 18.
18. And we have to account for this 0 because it's in a place value, right? If it's saying we have 0 ones, so we still have to count that. So we account for it by placing it down there. So 6 times 30 is 180. So 180. Again, make sure you're lining up your place values. And then 4 plus 0 is?
4 plus 0 equals 4.
And 8 plus 10 equals?
8 plus 10 equals 80.
Nice. 8 plus 2 equals?
10.
Equals 10. Am I writing 10 down here?
No.
What am I going to write down here? Jacob.
We carry the 1 and place it up to the 1. And we put the 0 to the
one
bottom.
to the hundreds.
We put the 1 to the hundredth place and we put the 0 on the 10th place.
Okay. And then 1 plus the 1 that we carried over is?
2.
Just 2. So 204. Okay. So, number 4. Who feels confident that they can walk us through this? Marika, you want to come walk us through it? You can bring your book up. We got to talk us through the whole thing. Okay? Okay.
So for problem 4 is 99 times 2.
Can you show us where that is? Like, everyone follow where Marika's at?
Yes.
Okay, 99 times 2.
We're gonna do 9 from the 1 and 9 times 2 to get 18.
And where is that on the area model?
Right here.
Yeah. So we want to write 18 in that box? 18, perfect.
And then for 90 times 2 to get 180.
Yeah.
And write it in the aerial model. And then you add it to get 8 plus 0 is 8. 1 plus 8 equals 9. And 1 plus nothing equals 1. And your answer is 198.
That was great, Marika, thank you. That was perfect. Do you guys think you can do number 4 on your own?
Yes.
Okay, why don't you guys go ahead and do that. I'll walk around if you guys need help. Number 4. Oh, I'm sorry, you're right. He just did number 4. Number 5. I'll come walk around, and if you have questions, I can come help you. But try to do number 5. I'll give you guys 3 minutes. Where's my timer? Oops, sorry. What's the first thing you have to do? Is it first 3 times 5? Is that 15? some of you guys using highlighters, so if that helps your brain, feel free to use the highlighters. I love highlighting my ones and my answer for multiplying my ones together the same color. Same with the tens and the hundreds. So if that helps your brain figure it out, go for it. And I know that you can add 185 3 times, and you won't be wrong. But this is showing you a different way of how to do that same math. So try to practice doing this math instead of adding 185 3 times. And I'm gonna ask you guys, do you see how in number 3, I put my answer for each of those multiplication problems within that box of the area model? Can you please write your answers in the area model, just so that when you go back, you can see that if I got the answer wrong on number 3, I would be able to know that, oh, it wasn't 18,000. I would know that this is where I messed up, and this is what I would need to fix to try again. Owen, can you tell me the first thing you did on number 5?
The first thing I did on number 5 was I multiplied 3 times 100. The first thing I did on number 5 was I multiplied 3 and 100.
This one right here?
Yeah.
And what did you get?
I got 300.
Okay, that's right. But when we do this math, where do we start? Do we start at the hundreds? Where do we start? At the ones. So can you tell me what you would do first if you started at the ones?
We would multiply 5 and 3.
5 and 3. And 5 times 3 is what, class?
15.
15. I'm going to stack it. It works for my brain. 15. What's the next thing I would do on this equation? Kartik?
80 times 3.
80 times 3. And what did you get for 80 times 3?
240.
240. And the last thing, what would I need to do, Harper?
I multiply 3 times 100.
3 times 100, and what did you get?
3,000.
3,000? Marika? Yes?
Argument, I think it would be 300.
You think it'd be 300, not 3,000? And what's your argument for that?
Cause you're multiplying 100 place.
You're multiplying up to the hundreds place. And 3 times 1 in the hundreds place is?
300.
300. I would agree with Marika. 300, not 3,000. And then what's next? What do we do after that? Zoe?
Oh no, I just wanted to walk through the next problem.
Oh, okay. Not quite there yet. Jacob?
We add the whole number that we have.
Yeah, we add up these 3 numbers?
Yes.
Perfect. Thank you, Jacob. And can someone tell me what they got? Sarah, what did you get? Is that not what you were raising your hand for? Cassie?
I got 555.
555. We feeling pretty solid with this?
Yes.
I see 4s and 5s. Is to 5? Okay. I'm gonna leave 6 for you guys to do later. Let's go to the back and see if there's something back here that we can. All right, so before I let you guys go off into independent practice, let's do number 8. This is asking why it said he used partial products to write 7 times 870 to equal 560 plus 49. Can you explain why it's error and use math to justify it? I think he might have messed up his place values. If he multiplied 7 times 0, what would that be? 0. And is it 7 times 7 or 7 times 7 tenths?
7 times 7 tenths.
And what is 7 times 7 tenths?
400.
400 what?
490.
490. Right? Okay. And then the last thing that he would need to do is 7 times
8.
Owen?
7 times 8.
Everybody agree with Owen?
Yeah.
No? I'm not very good.
He said 8, even though the 8 is a
Oh yeah, 800.
So it would be 800.
Yeah, so 7 times 800. You can do the math of 8 times 7. That's smaller, easier for your brain, but you have to remember these place values because these mean something. 56 is very different than 5,600. I just gave you the answer. Yeah, 5,600. So if he got 5,600. Did we get 5,600?
Yes.
Yes. He got 49. Did we get 49?
No.
What did we get?
490.
490. What do you think his mistake was? Owen?
It was like what I just did right now. I didn't use the place value on the hundreds, and instead I used the ones.
The ones, yeah. So instead of doing 7 times 7 tens, he just did 7 times 7. Yeah. He didn't use his place values correctly. Alright guys, to start off your independent practice, I'm going to say you guys, please start with number 9 and then we'll switch notebooks.